All right, I've started recording. So let's get started. When we say change of subject formula, in physics, you have a lot of formulas in physics. Am I right? You have a lot of formulas in physics. Some of them from the basic formula for distance, where you have, it's not everything you write, so please listen. Most of the time you should be listening. Try to understand. In physics, we have several formulas. Some of them include the ones like distance is equals to velocity times time. Why am I hearing that spinning sound? Hello, are you guys with me? Are you guys with me?
Yeah.
Sorry, it's you.
Hello, are you guys with me?
So,
Yes, sir.
Okay. So most formulas in physics require to solve the formula. What does change solve formula means? It's making the term you are looking for to be equal to the other part of the formula. Let me explain something. So in a question, you can be given time and velocity. Using this formula, you don't need to change subject formula. It's just v times t. So for example, your velocity is 50 meters per second times your time. Let's say your time is 3 seconds. You multiply it, you get 150 meters. But what if you're not still seeing my screen? Are you seeing the screen now? All right. So don't worry. If some parts or break due to network, I'm recording it so later you can go over it. Okay. So let's get back to what I was trying to say. So in a situation where you are given the distance instead, and you're asked to find, maybe for example, you're asked to find time, you have to change the subject formula for time to be equal to the rest of the terms. So to change subject formula, we're going to use a very basic method. So the main formula is d is equals to velocity times time. Now make time subject of formula. How do we do that? We want only time to stand alone. There is a very easy way we can do that. This v here is what is making time not stand alone, right? So if we divide both sides by v, v we cancel out from here, and we're going to be left with time only, right? So time is now going to be equals to distance over velocity. Does that make sense? I need feedback, so please let me know you are with me.
yes, sir. Yes, sir.
Yes.
Okay. Okay. So this is just a basic form of changing subject or formula. This is just a basic form. We have other complex ones. Let's say, for example, let's take the third equation of motion. V square is equal to U square minus 2GH. I have a question for you. What is the subject or formula in this equation? In this equation I just wrote down. Tell me what the subject or formula is.
V squared.
B square. B
The
square.
subject or formula is V squared, right? So now let's say in our question they gave us V. They gave us V. They gave us U. They gave us G. We have V, we have U, and we have G. Then they asked us to find the height. We have to make the height in this equation the subject of formula. How do we make height the subject of formula? How do we do that? Collect like terms, first of all. It's not about collecting like terms. It's about moving the terms you don't need over to the other side. And you know, whenever a sign crosses the equal to sign, it changes. Whenever negative or positive crosses over the equal to sign, it changes to the opposite sign. So let's say, for example, we want to move minus 2GH over to this side. It will change to plus 2GH. Are you listening? So I can go about this with two ways. I can use two ways to go about this. The first method would be just to eliminate all the terms from this side, so we can make 2GH. You know, H is together with 2GH. So we have to separate the other terms that are not needed first. So this is how we're going to go about it. There is a plus behind V square. There is a plus behind U square. I hope you know about that. So let's remove U square from this side and bring it over to this side. That's what I want to do now. So U square over to the other side will become what? It will become V square minus U squared equals to, what are we going to be left with on this side? What are we going to be left with? We're going to be left with what?
2GH.
With what? I didn't hear you well. Minus 2GH. So minus 2GH. And then what next? How do we separate H? Remember what we did here. When we had D equals VT, how did we make time stand alone? How did we make time here stand alone? What did we do? That's the exact same thing we're going to do here. What did we do? What is making H not stand alone? What is making H not stand alone?
Minus 2G. We divide both sides by minus 2G. Yes,
exactly. Sir. So now we have to divide both sides by that thing that is making it not stand alone. So dividing both sides by minus 2G, you see minus 2G cancels out, and now we're left with H is equals to what? V squared minus U squared all over minus 2G. Does that make sense? So now with this formula, if you are given V, U, and G, you can easily put those values and just divide, and you get your value for H. Do you understand? I'm not getting feedback. Oh.
Yes, sir, we understand.
Okay. You said what? You said what? Okay, not talk again. Let me give you guys a classwork to do right now. So let's say, for example, this formula. I'm going to give you S is equals to UT plus 1 all over 2 GT squared. In this formula, I want you to make okay, this one is difficult. This one is difficult. Let me start with something easy first before I will. So V is equals to U plus AT. I want to make acceleration the subject of formula in this equation. Do that and send the image to the group now. I want to make acceleration the subject of formula. Are you seeing the equation? This one here. Make acceleration, that is A, the subject of formula. From what I've taught you so far. Perfect, perfect. I'm seeing some really perfect. Wow, very good. That is very, very good. That is very, very good. Okay, so now let's visit the question of yesterday. Do you know the question I'm talking about? That question involving horizontal component. Let me see if I can copy it and send. Give me a moment. Okay, I've seen the question. Okay, let's revisit this question that you guys were failing. You guys were failing anyhow yesterday, or somewhat solving rubbish. I'm going to use that term. Yes. Okay. So the question said, can somebody read the question to me, please? Are you guys on the call? Someone should read the question to me. The question I just sent to the group.
The horizontal component of the initial speed of a particle projected at 30 degrees to the horizontal is 50 meters per second. If the acceleration of free fall due to gravity 10
Wait,
meters
don't
per
just read.
second
Stop. Just read the question and stop.
Okay.
Can you come again, please? I can't hear you clearly.
Okay. The horizontal component of the initial speed of a particle projected at 30 degrees to the horizontal is 50 meters per second. If the acceleration of free fall...
Okay, stop there. Okay. Stop there. Oh.
Yes, sir.
Stop there and mute your mic. So they said the horizontal component of an initial velocity with angle inclined at what? 30 degrees to the horizontal. What this tells us is that, listen, what this tells us is that theta is equals to 30. Am I right? Now they said the horizontal component, let's call the horizontal component ux, is equals to what? The horizontal component is 50 meters per second. Are you with me? Now, what are they asking for? They're asking us to find the initial speed. U is equals to initial speed. And yesterday, I made it clear to you. I explained that the formula that relates the horizontal component of the speed to the initial speed is given by ux, that is the horizontal component, equals to u cos theta. Are we following?
No,
Let me know if you are with me. What is no, sir? What are you not following? Tell me where you are lost. Tell me where you are lost.
Please, can you recap from that? U is equals to initial speed.
There's nothing to recap. I told you before that the formula relating initial speed to its horizontal component, you know that ux is its horizontal component, is this formula I just gave you right here. The horizontal component of the speed is given by the speed, that is the initial speed, times theta. Do you understand now? Do you understand? It's like having network issues.
Having network issues.
Okay, so let's move on. So from this formula, what are we looking for? Is there only one student in this class? From this formula, what are we looking for?
Initial speed.
We are looking for initial speed.
So what should we do? Make U the subject of formula, right? Because that's what we're looking for. So right now, I want to make U the subject of the formula and send to the group while I do it here. From what I've taught you, how do we make use of the formula? In fact, let me just do it to save time. Because we have ux is equals to u cos theta. We want u to stand alone. We want only u to be at the side of the equal to sign. So to make use of the formula, we divide both sides by cos theta. Dividing both sides by cos theta cancels out cos theta here, and then we're left with ux over cos theta. So that just means that to find u, we have to divide ux all over cos theta. Therefore, we have to substitute what? Ux is what? Ux is 50 meters per second. So that is why we're 50 here. Because ux is 50 meters per second. So we're going to put 50 here. Does that make sense? Our theta is what? Our theta is 30 degrees. So that is why we're going to put what? Cos 30 here. So we'll now say cos 30. Cos 30 is what? 0.866. I told you before. Just memorize the value for sine. Cos 30 is the same thing as saying sine 60 degrees. And I know that sine 60 degrees is 0.866. And that is why I have this here. So on dividing this, you are going to get 57.7 meters per second. And that is your initial speed. Is that clear to you? Do you guys understand?
You understand?
Is there anyone that does not get it?
Sorry, sir. Please.
Is there
where did you
anybody
get?
that does not get it?
Yes.
Where did I get what?
Where do you get the 0.866?
These are constant values. Do you understand? These are constant values. If you press cos 30 in a scientific calculator, you are going to get 0.866. If you press cos 30 in a scientific calculator, you are going to get 0.866. But I told you yesterday that you don't have cos or sine in your JAMB calculator. So what you should do is to learn the values. You have to cram them. You have to memorize them. You know that sine 0 degree is equals to what? Is equals to 0. You know that sine 30 degrees is equals to what? 0.5. Cram these values I'm giving you now. Memorize them. You know that sine 45 degrees is equals to 0.707. We know that sine 60 degrees is equals to 0.866. We know that sine 90 degrees is equals to 1. Are we following? So these are the values for sine you should memorize. This is the value for sine you should memorize. Memorize all these values here. So I want you to memorize all these values. After memorizing them, to get the cosine, to get the cos, you have to invert. Are we following? So sine 0 degree equals to cos 90 degrees. So sine 0 is the same thing as saying what? Cos 90. Sine 30 is going to be the same. Is going to be the same thing as saying cos 30, cos 60 degrees. You just invert it. If you see, if you look very well, we had 0 at the top for sine. But we're going to have 0 at the bottom for cos. We had 90 at the top for sine. We're going to have 90 at the top for cos. Do you see how we're inverting? So yeah, in the second position, we had 30. But for cos, we're going to have 30 in the second to last position. So you just have to invert the values to get the equivalent in cosine. So now watch. Sine 30 degrees is as cos 60, which is 0.5, right? Cos 90 is what? 0, because sine 0 degree is 0. Sine 45 and cos 45 have the same value because they correspond at the middle. That is 0.707. Sine 60 degrees is the same thing as saying cos 30 degrees, which is what? 0.866. Sine 90 degrees, sine 90, what are we going to say here? Cos what? Remember, we're inverting. So it's now what? Cos 0 degrees. Cos 0 is now going to be equal to what? It's now going to be equal to 1. So if you look back here, that was how I knew that cos 30 you are saying is equals to 0.866. Do you understand that?
Yes.
Yes, sir.
The person that asked the question.
Yes, sir.
So when we made u subject formula here, we got u is equals to ux all over cos theta. Am I right? So what is the value for ux? We said the value for ux was what? 50 meters per second. So all over cos theta. Cos theta, what is the value for theta? The value for theta is 30 degrees. So we say cos 30. Therefore, u is equals to what? 50 all over. What is cos 30 degrees? Cos 30 degrees is 0.86. It's the same value you get when you press your calculator. You have cos and sine in your JAMB calculator. So that's why you just write it directly, 0.866. And then you get what? 57.7 meters per second. I hope that's clear enough. I hope that's clear. At the
It's clear, sir. It's
okay,
clear, sir.
so the number 2 part of the question. What does number 2 part of the question ask you? They said what? Sorry. The II part of the question. What does it say? There's no II part.
Speed at maximum height reached.
Okay, speed at maximum height reach. Now, I told you in class yesterday that a projectile launched at an angle theta would fly up as it's going further, but it will reach a maximum height where it can no longer go upwards, but now continues to what? Fall down. At this maximum height, it is no longer going up. That means what? The vertical component is equals to 0. But the horizontal component, so we only have ux. That is the horizontal component of velocity at maximum height. So the question says you should calculate the speed. Calculate the speed at max height. What is the speed at maximum height? It's simply ux. That's the speed at maximum height. And what is ux?
50 meters per second.
50 meters per second. So your answer, therefore, ux is equals to what? 50 meters per second, which is speed at maximum height. That's the end. You don't really need to solve anything for this one. Is it clear to everyone?
Yes, sir.
Okay. I believe everyone understood that too. If you are not clear on something, this is a beginner class. So as many times as you want me to explain, I will explain. Then what?
Explain the bit again.
Explain what?
part, like the speed at maximum height again.
Okay. So now this is just concept. This is just physics concept. Now I told you before in projectile, when you launch a projectile from the ground at an angle, you see it's going to be going up axis. This is the y-axis, right? This is the x-axis. Are you seeing this? So when you launch a projectile at an angle, it's going to be going up. You see the value is increasing. Let me put some values here. Let's say this is 0. This is 1, 2, 3, 4, 5, for example. And then here you have 1, 2, 3, 4, 5, 6, 7. In fact, you know what? Forget about this. Let's focus on the vertical component. So the body comes to the ground, but it first reaches a maximum height. A maximum height where it no longer goes upwards. You see that from here, you can see trace 1, you can see trace 2 here, right? That shows what? That shows the height is increasing, Abi. Are you seeing these dots I'm tracing? That shows the height is increasing. But it will reach a point where the height no longer increases. Did you see that the curve reaches here? No. It just means that the velocity, the vertical component, it has finished at maximum height. That is why the height is not increasing. So it means uy is equals to 0. But the horizontal component persists. It remains because the object is still what? It's still moving towards this side. But it has stopped moving upwards, but it's still moving towards this direction. That is why there's still ux. So when they say calculate the velocity or the speed of the object at maximum height, you should know that the vertical component, there's no vertical component, there's just only horizontal component. And that is given in our question as what? 50 meters per second. What's the formula for vertical component? Ux is equals to what? U cos theta. I hope this thing is clear. At maximum height, this is the formula for the speed. Just take it like that. This is the formula for speed at maximum height. Is that clear?
Yes, sir.
Okay. So
Yes,
let's take
sir.
another question. Let's take another question. Which question from class did you not understand? Which other question? Oh? Let me find one. Okay, so I'm going to paste those questions which I solved earlier. Two, three. Okay. All right, check the group chat. Check the group chat. We're going to be solving those 10 questions. So you follow along and see how we actually solved in real time, and so you can ask your questions. Can you still see my screen?
Yes.
Yes,
Sir.
sir. That's still same.
Okay, so question one. Question one, somebody read the question.
Start from rest and accelerate uniformly at 3 meters per second square for 10 seconds. What is its final velocity?
Okay, thank you very much for that question. The first thing you should do when solving a physics question is to write down your parameters. You can forget every other thing except formula, sha. You can forget every other thing, but do not forget to write down your parameters. So when these students read the question, what's your name? The person that read the question. Who read the question just now? Hello, can you hear me? What's your name?
I don't know.
I can't hear anything. No.
I read it again. My network is doing somehow.
Okay, so as I was saying, the first thing you should do is write down your parameters. Can another student read it? Read the question. So we can start writing down parameters as the person is reading.
A
A
car
car
starts
A car
starts
starts from rest and accelerates uniformly at 3 meters per
Oh yeah,
second square.
wait. Don't rush. Read it slowly. You're not reading a novel. You are trying to understand the question. So let's go again. Read the question
A car
slowly.
starts from rest.
From
A
what?
car
From rest. When you hear from rest, wait, calm down. When you hear from rest, what this tells you is that the initial speed is equals to 0. Oh yeah, continue. From rest,
and accelerates uniformly at 3 meters per second square.
it accelerates. That means the acceleration is what? The acceleration is 3 meters per second squared. Oh yeah, continue reading.
For 10 seconds.
For 10 seconds, it means the time is what? 10 seconds. Reading.
What is its final velocity?
What is its final velocity? So we're looking for what? V, which is final velocity. This is what we're looking for. Now that we've written our parameters, we can now figure out which equation of motion can help us solve this question. So you must memorize the equation of motion. You must cram it if possible, if that's what will make you understand. cram the equation of motion, the three main equation of motion. So what's our first equation of motion? Let's write that down first. So our first equation of motion is V is equals to U plus AT. Our second equation of motion is what? S is equals to UT plus, or I like saying plus or minus because can be negative sometimes. I will tell you when it's negative. UT plus what? 1 over 2 GT, sorry, AT square. Remember, we're dealing with linear motion. When it's motion under gravity, this acceleration becomes what? G. It becomes acceleration to gravity. Then the third equation of motion is what? V squared is equals to U squared plus 2GS. Are you guys with me? So now we have to figure out which of these equations are we going to use. Which of these three? And how do we do that? You can do it by inspection. So we are looking for V. We have to use an equation that has V inside. Give me feedback now. Give me feedback. Are you listening? Are you with me?
Yes, sir.
And
Yes,
giving me feedback.
Yes.
So we're looking for V. So we have to use an equation that has V inside. Does this equation have V inside? This first one.
Yes.
Does number one?
Yes, sir.
So let's take this one. Does number 2 have V inside?
No, sir.
No, sir.
No.
We cannot use this equation. Does number 3 have V inside?
Yes, sir. Yes, sir.
Yes. Yes. Probably we can use this equation. Probably. Now, what about the other terms? U. Each of these equations have U, so we cannot use that to justify. What about acceleration? We're focused on 1 and 3 now. In equation 1, does it have acceleration?
Yes, sir.
Yes, sir.
Does it have A? So,
Yes, sir.
2 ticks. Now let's go back to equation 3, because this one is already out. Equation 2 is already out. We cannot use it. Equation 3, is there acceleration?
No, sir.
No, sir.
Yes, there's acceleration.
Yes, sir.
There's acceleration. This is acceleration to gravity. I made a mistake. Acceleration to gravity is the same thing as acceleration. This is the formula. Let me write this again. 2AS. Remember, G is the same thing as acceleration. So there's acceleration 2 as well. Abi? Second tick. What's the last term? Time.
Time.
Time, Abi. So is there time in equation 1?
Yes.
Yes, sir.
There's time, sir.
We cannot use, remember, we cannot use equation 2 again. No. Equation 2 is out of this debate. Equation 3 is there time. In equation 3, time.
No, sir.
No time, sir.
There is no time.
So equation 3 is now out as well. Since we cannot use equation 2 and we cannot use equation 3, therefore equation 1 is what we should use. And you have to think about this very, very fast. By inspecting the equations, you have to think very fast because you don't have much time in JAMB. So that equation 1 is the one we should use. V is equals to what? U plus 8t. Let's say we should calculate what? The final velocity after 10 seconds, Abi. So what do we do? Make V subject of formula. V is already subject of formula. So just substitute. U is what? 0, right? A is what? A is 3 meters per second times what? Times the time. The time is 10 seconds, Abi. So what? V is equals to 30 meters per second. And that's our final answer. Is that one understood?
Yes, sir.
Yes, sir.
Okay, let's go to another question. No questions, Abi. No questions, Abi. Oh yeah, question 2. Somebody read me question 2. Anybody now? Anybody can
Train
read.
moving with
We
A
use the first
train
equation.
a train moving with an initial velocity of a train moving with an initial velocity of 20 meters per second
Yeah, stop there first. Initial
decelerates
velocity. Wait
uniformly.
now. I told you to always read slowly. Read slowly, for God's sake, please. Initial velocity of what?
Of 20 meters per second.
So write that first. That means our U is what? 20 meters per second. Yeah, continue reading.
Decelerates uniformly at 4 meters per second square.
Remember, deceleration is negative acceleration. So our acceleration is what? What? What did you say?
4 meters per second minus 4 meters per second square.
Okay, you can use minus. You can put minus there if you want, but don't worry. Don't worry about signs, please. Just write acceleration square. Next.
For 5 seconds.
For 5 seconds. That means time is what? 5 seconds. Next.
Is 5. What is its final velocity?
Its final velocity. So we're looking for V again. Can somebody tell me which equation of motion we can use to find V?
The first equation of motion.
The first equation of motion again. Abi?
Yes, sir.
So V is equals to U. What is U? Okay, U plus 80. So V is equals to 20, right?
20.
Plus. Now, note something, please. Remember I said we should the minus. It's because I want you to understand the concept. If a body is coming to rest, wait to they say we should find final velocity after 5 seconds, Abi. Hello?
Yes.
Okay, so please take this correction. We're given deceleration. Now, deceleration, listen, deceleration is negative acceleration. Do you understand what I'm saying? So, since they said deceleration, that means the body is coming to rest. So, it is negative that value, 4 meters per second square. So, when we're substituting in our equation for acceleration, we don't just put the value there. We change the sign to negative. So, let's change the sign to negative from plus to what? Minus 4 meters per second times what? Time, Abi? What is time? 5 seconds. So now simplify. Tell me what you get. Are you sure you read this question correctly? Are you sure you're looking for final velocity?
Yes, sir. We're looking for final velocity.
What I'm seeing here is 0.
Yes. The answer is 0.
The answer is 0, Abi.
Yes, sir.
Okay, so the answer is 0 meters per second. That means it came to what? It came to rest completely. We understand that one, ba? Oh yeah, number 3. Let's go.
A particle moves with a constant acceleration of 5 meters per second square.
Constant acceleration. So our A is equals to 5 meters per second square. Oh yeah, next one.
If it starts from rest, how far will it travel in
Wait.
6 seconds?
Okay, from rest, it means our what? It means u is equals to 0, right? Now they're asking
Yes,
us how
sir.
far will it travel in how many seconds?
In 6 seconds.
So t is equals to 6. Now we have to figure out which equation of motion we should use. How do we do that? Well, they're asking us how far. What are we calculating? We are calculating distance. Distance is s. So this is what we're looking for. So which equation of motion should we use? That's the question.
Equation.
Let's write out the equation of motion. V. Wait. Let me write them down so you can understand. I don't want to hear unnecessary questions. V equals to u plus at, equation 1. Equation 2. S is equals to ut plus 1 over 2 gt squared. Equation 3. V squared is equals to u squared plus 2. Sorry, why am I always using g? I always make this mistake. G is the same thing as acceleration. So please, it's not really a mistake. Just that one is used for motion under gravity and the other is used for linear motion. That's just the difference. So 2as. Now we're looking for s. Looking for s. What happened now?
So we are no longer seeing your screen.
Yeah, I'm aware. I'm aware. Can you see it now? You can see it now, Abi. Okay. So where was I? We're looking for distance s. Does equation 1 have distance?
No, sir.
Does this first equation have distance?
No, sir.
No, sir.
No. This one is out. Does the second equation have distance?
Yes.
Sir.
Yes, sir.
There's
Yes.
s, Abi. So this one is in.
Yes, sir.
Does equation 3 have distance?
No.
Yes, sir.
No, sir.
Yes, it has this.
Yes, it has. CS here. That's distance. This one is in. Okay, let's choose one between these two that were selected. So next thing I'm seeing here is time. Acceleration, definitely both of them have acceleration, right? Equation 2 has acceleration. Equation 3 has acceleration. But time, can you mute your mic, please? Mute your mic, I beg. Now time, does equation 3 have time?
No.
No, sir.
Look at equation 3.
No, sir.
So it does not have time, meaning that we cannot use this one. We cannot use stroking it off. That means the one we can use is what? Equation 2. So all you have to do is what? Write down your formula. S equals to ut plus 1 over 2 at squared. Then substitute. What is our initial velocity? 0. Can you see that?
0.
0. So S is equals to 0 times time. We don't need to write the time here because 0 times 0 is still what? Is still 0. So we can just, in fact, to make life easy, let's just say 0 completely. Let's just call this part 0. 0 plus 1 over 2 times, what's our acceleration? Acceleration is 5. Times what? T squared. What is time? 6 seconds. So 6 squared. Let's simplify. 1 over 2 times 5 is 2.5. Or, you know what? Let's make this easy for us. 6 squared is what? What is 6 times 6?
36.
6 times 6 is 36. Learn to solve with a calculator, please. Please learn to solve with a
36.
calculator. I know, yes, I've written it already. I'm trying to emphasize a point that you should learn to solve with a calculator. So I've written 36 here. 6 times 6 is 36, right? 1 over 2.
Yes, sir.
1 over 2 times 36 is saying, is saying 36 over 2. So 36 over 2. 2 here. 2 into 3 is what?
1 remainder 1.
1 remainder 1. So you put the remainder behind the 16. I mean behind 6. So you have 16. 2 divided 16 is what?
8.
8. So 2 divide. So 36 over 2 is 18. Is that clear? So we have 18.
Yes, sir.
So therefore we have 18 times what? That's 5. 5 times 18 is what?
1 remainder 1.
90.
1 remainder 1. 1 remainder 1.
So I can do this without calculator. I can just say 5 times 10 times. Sorry, I can just say 5 times 10 brackets plus brackets 5 times 8. 5 times 10 is 50. 5 times 8 is 40. So we got what? We got 90 meters. Is that understood?
Yes, sir. Definitely.
Oh yeah, let's go to the fourth equation. You have taken light here. Oh. I just pray my laptop don't go off before I'm done. All right, so read the fourth question.
Car travels from Benin to Lagos in 3 hours.
Okay, so time to Benin to Lagos.
In
Time
3
3
hours.
hours. Okay.
But
Next.
when coming back, spends 5 hours.
Okay, so coming back, that is Lagos to Benin. It's 5 hours.
5
okay.
hours. If the distance from Benin to Lagos is 900 kilometers.
Okay, so distance is equals to 900 kilometers. All right.
Yes, sir. What was the car's average speed?
The car's average speed. So they're asking us for what? Average speed. First thing you ask yourself, what is the formula for average speed? Average speed is equals to what? Total distance over total time. As simple as that. So remember, we went from Benin to Lagos. It took us what? Hours. I mean, it took us 3 hours. Abi? It took us 3 hours, but we traveled how many? What's the distance we traveled? 900 kilometers going. Now we came back. Coming back, I should have written this thing. Anyway, coming back from Lagos to Benin, we spent what? We spent 5 hours. And we traveled another 900 kilometers. So that's to tell you that the total distance is what? The total distance is 900 kilometers plus 900 kilometers going and coming back. Abi? Or we can say what? Or we can say 900 times 2 going and coming. That is the total distance. What about the total time? We spent what? 3 hours going and we spent 5 hours coming. So 5 plus is I'm waiting. 5 plus 3 is 8. So 8 hours. Are we following? So from here, we can start to simplify. Immediately, we can start simplifying from here. 2 here, cancel out. We're left with 1. 2 here. 2 divided 8 is what?
4.
4. So we're left with 4 here. So we have 900 over 4. How do we divide again? We can simplify. Start from 2, or we can use 4 directly. But let's just start with 2. So 2 here, we have 2. 2 divided 900 is what? 2 divided 900 is what? You have to say 2 divide 90. 2 divided 90 is 45. Therefore, what is that one saying? What did you say? So 900 over 2 is 450. So I left with 450 here, right? And we're left with 2 here. So 450 over 2. So 450 divided by 2, what are we going to get? Now, I can easily press this in my calculator, but I want to teach you guys that you should be able to solve quickly without even using calculator. So 2 into 4. We can start with that. 2 into 4 is what? Let me write it big. Let me write it big here so you can see it. 2 into 4 is what? 2. Abi?
Yes.
No remainder. 2 into 5.
2 remainder 1.
2 remainder 1. Who does not understand how it is 2 remainder 1?
What you are working is not showing.
Who does not understand how 5 divided 2 is 2 remainder 1? Who does not understand how it's 2 remainder 1? Nobody, Abi. That means you have the knowledge of that already. So 2 remainder 1. So we put 2 here. You put what? 1 behind. That remainder 1 behind is 0. 10 divided by 2 is what?
5.
Is 5. So we have what? 5. Therefore, our final answer is 225 meters. And I did this without using a calculator.
This one is very easy than others.
No, we'll take hard ones now. Look at the remaining questions. The remaining questions from the ones I sent, let me know if it's something I should go through or not, so we can rush to something more complex. Let me know when you're done going through the questions. Please hurry up, oh, we don't have time, please. Time is of essence. And my laptop will soon go off.
So I think we can use these ones as assignments for now. Then you go to more complex ones. So submit these ones.
Your voice is not audible. I cannot hear you clearly. Because my laptop speaker is low. I can't hear you clearly.
I said I think we can use this one for assignment. Then you go to the more complex ones. Then tomorrow we'll submit these ones. You see where the
Submit questions. I've already solved them. Those questions I already solved them now. I'm just asking to know if there's anyone there you don't understand.
Okay, yes.
So it's left for you to tell me, yes, I understand the other ones. From number 5 to 10, I understand them. Yes, we should move on. We can already solve them there.
Let's move on.
Okay. So if you can solve question 8. If you can solve question 8.
The number 10
Question
too.
8. Oh, yeah, read the question.
Question 8. Question
10.
8. Question 8 is
Read the question.
a particle starts from rest.
From rest. When you hear from rest, it means what?
A
It means u
particle
is equal to 0.
is 0, yes. Accelerates
Continue.
uniformly at 2 meters per second square. What is
Accelerate
velocity? Uniformly at
2 meters per second square.
Yes.
Okay.
What is its velocity after covering
What
a
is its
distance of
velocity?
50 meters?
After covering the distance of 50
meter. 50 meter.
50 meter.
Yes.
So we're looking for V. Now, which formula can we use? Okay, let's write down our equation of motion. Let's not rush. Let's not rush too much. So first equation of motion. V U plus 8t. Second equation of motion is what? S is equals to ut plus 1 over 2 at squared. Third one is what? V squared is equals to u squared plus 2as. Okay, so I'm looking for V. Does equation 1 have V? Yes or no? Just answer yes or no. Are you guys not there?
Pardon?
We are here,
Does
sir.
equation 1 has V? Yes. Does equation 2 have V?
No.
So we cannot use equation 2. Does equation 3 have V?
Yes.
Yes, sir.
Yes, sir.
So equation 3 might be used. Okay, what other thing can we use to differentiate? Acceleration. So equation 1 has acceleration, equation 3 has acceleration. What about distance? Does equation 1 have distance?
No.
No.
Sir.
No. We cannot use equation 1. Equation 3, does it have distance? Yes. So equation 3 is the way to go. So equation 3 is the way to go. That's how we choose the formula we should use. So now we're using equation 3. V squared is equals to u squared plus 2as. Just substitute. What I'm looking for, V. This is even very easy. V squared is equals to u squared. U is 0. Since it started from rest, right? So 0 plus 2as. 2 times acceleration. Acceleration is 2. Right? From here. Times distance. Distance is what? 50. Times 50. This is very easy. So 2 times 2, 4. 4 times 50 is what? 4 times 5 is 20. So 4 times 50 is going to be what? 200. Now, our velocity is going to be what? Square root of 200. Who knows why it is square root?
Because of the squared.
Good. We have to what? Take the square root of both sides. That's actually what it means. So taking the square root of both sides, we are going to cancel that square from the V. So square root cancel the square. We are going to be left with what? V is equals to square root of 200. So what is the square root of 200? I know if I ask you easily, what is the square root of 100? You are going to tell me it is 10. True or false? Because 10 times 10 is what? Because 10 times 10 is 100. Abi? That one is very easy. But now when they ask you, square root of 200 is what? 200 is not a perfect square. And because it's not a perfect square, listen now, because it's not a perfect square, you cannot get one single value. You cannot just get one value. Okay, say 200 is, just like we said 10 for 100. You don't have a perfect value for the square root of 200. You're going to get decimal points. And because you're going to get decimal points, I advise you express it in what? In surd form. Now let's look at what surd form is like. So square root of 200. We're going to break down 200 into smaller portions so that we can take the square root until we get the simplest form. So 200, do you agree with me that 200 is the same thing as saying 100 times 2?
Yes.
Yes. We can call.
Yes, sir.
So 100 times 2 is the same thing as 200. Now, 100 is what? What is the square root of 100?
10.
10. 10 is the square root of 100. Okay,
Yes.
let me teach you something. Square roots like this is the same thing as saying, this is the same thing as saying square root of 100 times square root of 2. This is the same thing. These two are the same. So square root of 100 is equal to 10. So we have 10 times what? Times root 2. So our answer is what? 10 root 2 meters. Is that understood? We've got 10 root 2. So is there any way to simplify this further? No. This is our final answer. Now, if you press your calculator, you're going to get, I think you are going to get, root 2 is 1 point something. I think 1.4 something or so. Right? So your answer is going to be at the range of, wait, what am I doing? Okay, your answer is going to be 14 point something. But I don't know what exactly. 12 times 12, 144. 13 times 13, 160, 169. 14 times 14 is what? Two 20. 14 times 14 is 225, Abby. The point I'm trying to make is we may not know the value exactly, but we can get an approximate. And surd allows us to get that approximate. So 10 root 2 is the approximate value. In fact, it is the exact value. What am I even saying? This is the exact value for square root of 200. If you press square root of 200, you're going to get a map. So pull on and just punch that in. Or someone do that for me right now. What is square root of 200 exactly?
It's 14.14.
14.14, Abby. That was
Yes,
what I was
sir.
trying to explain. So that's what I was trying to explain. When I was saying 10 times root 2, we know that root 2, in fact, we don't know. But we can tell that square root of root 2 is around 1.4 something. So 10 times 1.4 is going to give us 14 points. We don't know what the decimal is. But that's like an approximate value. So if you see in your option 14.4 meters, wouldn't you know the answer? Wouldn't you know that that's the answer? Of course you would. Now, if you see in your option in short form 10 root 2, you also know that this is the answer to pick. I hope that's clear enough. Do you all understand?
Yes, sir.
Is there any other question I should solve?
Sir, I have a
Number
question.
10. Which comes number 10?
Who has a question?
They
Ask a question,
for
please.
They ask for equation 4. Number 10.
Equation 4.
Yes.
Yeah, read the question. Read the question to me. Fast.
cyclists increase their speed from 6 meters per second to 12 meters per second over 3 seconds.
You are not.
What?
Wait. Read it again. Read again. I didn't get you the first time.
I'm sorry, I made a mistake. It's number 9.
Oh yeah, read now.
A car traveling at 20 meters per second applies brake
Okay.
and comes to rest after 5 seconds.
So wait, calm down. Slowly. Take it slowly. 20 meters per second. It's traveling at initial speed of 20 meters per second. Okay.
Applies brake and comes to rest after 5 seconds.
Comes to rest, meaning that the final velocity is 0. Meaning that the final velocity is 0. Then the time is what? After 5 seconds, Abi?
Yes. What is the distance covered during braking?
So what is the distance covered during braking?
Yes.
You have to calculate distance. Let's use our 3 equations of motion that we know. This one they're asking of a 4th equation. Although, yes, I gave you a 4th equation. It's derivation from these 3 equations of motion. And we're going to see why right now. So, let's write down our 3 equations of motion. First one, follow along. V is equals to U plus AT. Yeah, what is the second one? I want you guys to echo it to me. Second equation of motion.
X is equal to
S equals U1/2 AT squared.
All right. Third equation of motion.
V square is equal to U square plus 2GX.
All right, let's look at which of these can solve this question. We're looking for S. We're looking for distance. Am I right?
Yes, sir.
Is there distance in equation 1?
No.
Do you see distance in equation 1? No.
No.
Do you see distance in equation 2?
Yes, sir.
Do you see distance in equation 3?
Yes.
Yes, sir.
Oh yeah. What? You want to ask a question? You want to ask a question?
I'm the one.
Oh yeah, next one. Time. Let's work on time. Do you see time in equation? You remember that equation 1 is out already. Do you see time in equation 2?
Yes.
Sir.
Do you see time in equation 3?
No.
No.
Next one. Next one, final velocity. Do you see final velocity in equation 2? Answer me now.
Yes.
There's for 2. Are you guessing or you are looking at facts?
No, we don't have final.
There's no final velocity in equation 2. Is there final velocity in equation 3?
Yes.
Yes, sir.
Now we're left with what? We're left with initial velocity. Is there initial velocity in equation 2?
Yes, sir.
Is there initial velocity in equation 3?
Yes, sir.
Yes.
Okay. So if you observe very well, we're going to see that none of these equations actually is sufficient enough to solve of this question. But if you check very well, for equation 2 and 3, what do we have missing? For equation 2, we saw that there was no final velocity. But indeed, we had initial velocity, right? And we had, what do they call it? Oh, thank God, they just brought the light back. Ah, no, they took it again. Now, wow. Stay with me, please. Stay with me. I want to drive at a point now. So, looking at this equation, we have to inspect it. Which one has all the terms required to solve for the unknown? We are looking for distance. We are looking for distance, right? So, looking at this formula, only 2 and 3 is capable of giving us distance. So, for equation 2, there is initial velocity, yes. There is time, yes. There is acceleration. No. Is there acceleration? No. We don't have acceleration. So the only thing missing in equation 2 is acceleration for us to find distance. For equation 3, what is missing? We have distance. Oh, there's also no acceleration. There's also no acceleration in equation 3. And in addition, there is no time as well. There is also no time too. So this is double red flag, which means we cannot use equation 3. All we have to do now is what? Find a way to find acceleration. And how can we find acceleration? From the parameters we have here, how can we find acceleration? We can find acceleration using what? Equation 1. Final velocity. We have initial velocity. And we have what? We have time. Is that understood? Are you guys with me?
Yes, sir.
Yes, sir.
So v plus 80. Let's first find acceleration. So what is our v? Our v is 0. Our u is what? 20 plus acceleration times time. What is time? 5 seconds. So times 5. Normally, we're supposed to make acceleration so your formula, Abi. Oh, yeah, you can still do it now. We can still do it now. And we've already done it before. So let's just continue like that. Remember, it is coming to rest. Are you seeing this? It is coming to rest. If an object, if a body is coming to rest, then it's what? Decelerating. That means this sign here is what? Negative. So whenever we're coming to rest, or negative sign. So move this over, you have what? 5a is equals to 20. Divide both sides by 5, you have a is equals to 20 over 5. So acceleration is equals to what? 4 meters per second square. Now that we have acceleration, we can then use that acceleration inside equation 2. To find our distance. So let's find our distance now. So this thing S is equals to UT. What is our U? U is 20, Abi. Time is what? 5 seconds plus 1 over 2. Are you guys seeing my screen?
Yes.
Plus 1 over 2 what? What's our A? The A we just calculated for is what? We calculated 4 meters per second square, Abi. And that is even deceleration. So it is negative. That's why we have to use what? Negative sign. So this has to be negative since we are coming to rest. Please take note of that too. Times what? T squared. What is time? Our time is what? Our time is 5 seconds. So 5 squared. Now 20 times 5 is what? 20 times 5 is 100. Let me use a brighter color. 20 times 5 is 100 minus 1 over 2 times 4 is same as saying 4 divided 2. That is 2. So 4 divided 2 is 2. 2 times 5 squared. 5 squared is same thing as saying 5 times 5, which is 25. So 100 minus 2 times 25. Are we following? So our distance is equal to 100 minus 50. Therefore, our distance is what? 50 meters. Hence the need for a fourth equation of motion. Because you can see these steps we have used is too long. It is very, very long, and we don't have luxury of time. So there's a shortcut formula. I would have looked to try is derived, but I don't want to confuse you further. But just know that there's a shortcut formula where we have V minus U T all over 2. Abi? So we make use of everything. So if you utilize this formula, it's going to be plus because it's plus V plus U. That's the formula. So 0 plus 20 times time. Time is what? 5 seconds. All over 2. 5 times 20 is what? 100. 100 over 2 is 50. So did you see that we got the same answer? Are you guys with me? Hello, are you guys with me?
Yes, sir.
Did you understand what I just did?
Sir, the time is 3 seconds.
Seconds. So why did you not tell me 5 seconds now? Now you read wrong question, give me. See, the solving is the same. Oh yeah, assignment. Using method 1 and method 2. Solve for the distance using 3 seconds. Do that now. So using this first method, which is long, and then using the shortcut formula, calculate for distance. This is the shortcut formula. Then we have the long method. So you have to first find acceleration using this formula, and then you go on to for in equation 2 to find distance. So do that right now. Start solving and snap your work, send to the group. Hope you understand the question. But we're going to use 3 seconds instead.
Okay, 3 seconds, not 5.
Your voice is very low. Are you sure you have... I can't hear you clearly.
I said, sir, please come again. My network kicked me out.
Come again with what?
The question I didn't let me just say for the past few minutes, I did not hear anything you said because of my network kicked me out.
Recording session. Later, the recording. I cannot keep on coming back again and again. We're recording it, so I will send the recording to the group. Okay, so I hope you got the assignment, Ja. You got the assignment. Send an assignment sentence. The difference between classwork and homework is that they are both assignments. Just that one, the time required for you to submit it. So this assignment I'm giving you is required to be submitted immediately. So do the assignment and submit now. All right, I need a complex question. Somebody read out a complex question to me. Look at the physics group. The physics group chats. Look for a question you do not understand or you're having issues with, and let's solve it right now. Look at the main physics group. Oh, I'm not talking about this group. The main physics group. And find any question you feel is difficult or you are not understanding. This is the time. Those friends that message me privately, you see private DMs with questions you say you don't understand. This is the time to talk about them now.
Jesus, Mama, my phone goes somewhere.
How many persons are on this call? Are you guys even following at all? Oluoma, I don't know how to pronounce her name, sorry. Oluomachi.
We are following, sir. We are following, sir.
Yes, I asked you for a question. So check the main physics group now. Find something you don't understand. Find a question. Those persons that have been disturbing me in my DM, that they don't understand. What don't you understand now? Start bringing them. Number 11 from where? Where did number 11 come from? I think we should just end this session here because apparently you guys are not ready. They're the one that have issue yet. You will not come
There is no
problem. Five PM, I'm ending this call.
Please, sir, I have a question. Sir, under upward motion. Please, are you hearing?
Yes.
Okay. So the question goes like this. A bullet fired vertically upwards from a gun held 2 meters above the ground reaches
Okay,
its maximum height in 4
calm down
seconds.
first. Read slowly, oh. Read slowly. You are not rushing
Okay,
to anywhere. You want to understand. It's not first to finish question. It's first to
okay, sir.
understand. So read slowly.
Okay. A bullet fired vertically upwards from a gun held 2 meters
Vertically
above the
upwards.
yes
So
from
the
a
gun was
gun.
held 2 meters above the ground.
Yes, sir.
So,
Reach,
oh yeah, wait. Let me
reaching.
draw something.
Okay.
Calm down. Let me draw something now. So we saw in the question that the gun was held 2 meters above the ground.
Yes, sir.
So let's just say this is 2 meters. I mean the bullet points. This point here. Am I right? This
Yes,
we need
sir.
to use imagination. No. So the bullet was fired from a point 2 meters above the ground. That's what I just drew. It was fired what? Vertically upwards. So let me draw a vertical line. Sorry about that. Vertically upwards. Okay, continue reading.
Okay. A bullet fired
Continue reading
vertically.
now.
Okay. From a gun held 2 meters above the ground reaches its maximum height in 4 seconds.
In 4 seconds. So it took T equals 4 seconds. Next.
Calculate the I magnitude of the initial velocity of the bullet.
Who is there? Evans, no, I don't think he's not around. He's not with he's with his power bank now. He's with his power bank. Okay, his power bank is here. Sorry about that. I'm back now. You can read the question.
Okay. Reaches its maximum height in 4 seconds. Calculate the I magnitude of the yes. I calculate the magnitude of the
Okay.
Yes, sir.
So this is the maximum height
in 4 seconds.
I already wrote that there. Can't you see T equals 4 seconds there?
Okay.
So this is the maximum height. I'm going to label it H.
Okay.
The gun, bullet was fired from a point 2 meters above the ground. I hope you can see the point where it was fired from. 2 meters above the ground, vertically upwards. And it reaches the maximum height. This is the distance. In what? In 4 seconds. So that's not to calculate what? The initial speed. That is U. U is equals to what? Abi, that's the I part of the question.
The magnitude of the initial velocity. So the
initial velocity is the same as initial speed.
Okay.
Speed and velocity are the same thing, just that one is a vector and the other is a what?
Scalar.
The other is a scalar. Which one is a vector and which one is a scalar?
Speed is a scalar, velocity is a vector.
Okay, so they are the same thing. They mean the same thing, just that one is in a particular direction. So to calculate the initial speed, we need to find a formula that we can use U for. Remember the acceleration to gravity, they gave us as what?
G.
As 10 meters per second squared. So we have this, we have this, we have this. Which formula can we use to find initial velocity? Let's write down the 3 equations of motion under gravity. So it's exactly like power bank. So it's exactly like normal equation of motion. The first one is what? V is equals to U plus 80. But in place of A, we're going to have what? G. Because A is what? Acceleration. So we are going to say GT. The second equation of motion is what? Do we say S?
H.
H, because it's what? We're not dealing with a vertical. We're dealing with a vertical distance now. This is no longer linear motion. So we say H is equals to what? UT plus 1 over 2.
GT.
1 over 2 what?
GT.
GT squared.
Yeah.
GT squared. So number 3, we have what? V squared is equals to what? U squared plus 2 what? G 2J. Because this is motion under gravity. Okay, so we need to find initial speed. Abi, let's ask ourselves, what is the final speed? First, what is the final velocity at maximum height? I'm asking you,
0.
what is the final velocity at maximum height?
0.
Why is it 0? Why is it 0? You can't explain why it's 0. Why is it 0? Why is the final velocity 0 at maximum height? You don't know why? Explain why. Answer me.
Yes, sir.
Okay. So when you throw a ball upwards, you throw a ball. Imagine yourself throwing a ball right now, or in fact, throw something upwards. It stops momentarily. It stops momentarily at the maximum height before coming back down. So because it stops, that is why the final velocity here at maximum height is equals to 0. And then it will start accelerating downwards again due to gravity until it reaches another velocity striking the ground. So do you understand why the velocity at maximum height is equal to 0 now?
Yes, sir.
Good. So now, which of this equation of motion can we use to find U? Is there U in equation 1?
Yes,
In
sir.
fact, there's U in all of them. There is U in all of them. Okay, now, what about G? There is G in all of them.
G in all of them.
What about T? There is no T in
3.
There is no T in equation 3. What about, what is left? Final velocity.
Equation 1 and 2. Okay.
So there is no final velocity in equation 2, Abi?
Yes.
That means the one we can use is what? Equation 1. So using equation 1, V is equals to U plus GT. What is V? V is 0, Abi. Let me wipe this off. V is 0, Abi. So we say 0 is equals to U is what? What is U? We are looking for U.
U.
We are looking for U. So G is what? G is 10, Abi. Time is what? What's the time given? The time given was what?
4 seconds.
So let's simplify. Now, I told you before, If an object is going against gravity, remember that gravity always acts downward, G. If it's going against, we're going to use negative sign in our equation because the body is coming to rest. Before at one height, it stops momentarily, but it's decreasing in speed as it's going up. So it's actually coming to rest. That's how we use what? A negative sign if the body is going up. So upward motion, we are going to use what? Negative sign here. All right, so move this one to the other side. Move this to the equation. We're going to have plus 10 times 4 is equals to u. 10 times 4 is what? 40. So our u is equals to 40 meters per second. Do you understand the first part of the question now?
Yes, sir.
So we understand I. Oh, yeah, read the second part of the question, the II part.
II, total distance of the bullet traveled by the time it hit the ground.
Okay, total distance traveled by the time it hits the ground. So we move up, we reach a maximum height, h, right? And then the bullets will surely fall back down. Abi? It will fall back down. So I'm going to draw a straight line of the bullet falling back down. So this is the bullet. It will drop back down. Definitely. But this time it's going to reach the ground level. So this is the ground level I'm drawing here. Are you with me?
Yes, sir.
So let us call this distance h, capital letter H. This distance, capital letter H. And I see clearly that this total distance is equal to the sum of the maximum height which the bullet reached when launched from a point 2 meters above the ground. This maximum height plus 2 meters is what constitutes H. Is that not true? You yourself, look at it now. H is the sum of small h plus 2 meters. This total distance from here to here, h plus what? 2 meters constitutes this entire distance, h. Is that clear?
Yes, sir.
Okay, so now they're asking us what is the total distance covered by the bullet. Now, what is the total distance covered by the bullet? Let's look at that. The bullet first left this point here. Let me use a bright color. The bullet first left this point. This point you are seeing here. It first left this point, moved upwards, fell back down through this distance. So we can safely say that the distance, the total distance covered is given by what? H, which is the maximum height it reached after being launched from a point 2 meters above the ground, plus what? Capital letter H, which is the distance it traveled when falling back down. Is that correct? Answer me now. Is that correct? And are you still with me?
Yes, sir.
And are you with me?
Yes, I'm with you. I'm with you.
Okay, so the total distance is given by what? The distance it took the bullet to go up and the distance through which it fell through before it reached the ground level. And that is what? Small h plus what? Capital letter H labeled there. So now what do we do to find the total distance? Simple. We have a clear goal. First of all, find what h, small h is. Then next, we can find what capital letter H would be. And then we add it and get our answer. So let's find small h first. To find small h, that is the distance, maximum height, we're going to use which formula? We're going to use which formula? Let's find out which formula we should use. Let's do elimination now. Sorry about that. Okay, let me wipe this off. Let's do elimination now. Equation 1. Can we use equation 1? Is there h in equation 1?
No, sir. No, sir.
That means we cannot use equation 1, Abi. Equation 2, is there h?
Yes, sir.
We can probably use equation 2. Equation 3, is there h?
No, sir.
Are you sure? Are you sure? Equation 3, is there h?
There is h, sir.
Yeah.
There is h. We can probably use equation 3. Oh yeah, let's keep on simplifying now. G, there's G in everything. There is U in everything, right? There is U in equation 2, there's U in equation 3. What about time?
There is time in equation 2.
There is time in equation 2, but there's no time in equation 3. But we don't need time to find it. Here is why, because the only things we have is sufficient. We just need, we have V, which is equal to 0. We have U. Oh, we solve for U. What did we say U was? We solve for U as what? 40 meters per second. So we have U. We also have what? G. That means we can solve for what? We can solve for H. So using third equation of motion, V squared is equals to U squared. Is it plus or minus? If you are going up, we use what? Negative sign. So minus 2GH. What's our V? The final velocity. Because at maximum height, the body stops momentarily before falling back down. So final velocity is equal to 0 squared. 0 squared is the same thing as 0. U squared, our U is 40 meters per second. So we have 40 squared minus what? 2 times G, which is 10, times the height, which we are looking for, H. Now move minus 2 times 10 times H over to the other side. We're going to have what? 40 squared. Sorry, let me just do this like this. So we are going to have plus 2 times 10. We're going to have plus 2 times 10 times H is equals to 40 squared. 40 squared is what? 1,600. How do I know this? 4 times 4 is what? 4 times 4 is 16. Plus 2 zeros. 1,600. That's how I got it. So 2 times 10, 20, to have 20H on this side. How do we find H now? Divide both sides by 20. And I'm left with what? H is equals to 16 over 20. So 16 divided 20. 0 cancels 0. 160 divided by 2 is 80. So we get 80 meters. Do you understand it up to this point?
Sir.
Yes, Abi.
Yes.
So we already have 80 meters as our H. What about capital letter H? Remember, the distance is equals to small h plus 2 coming down. So the distance coming from this maximum height down to the ground level is what? H plus 2. So we have H is equals to 80 80 plus 2 meters rather. 80 plus 2. So h is what? 82 meters. Now the total distance, since we have h as 82 meters, the total distance now is going to be what? 80 plus 82. So the total distance covered is 162 meters. That's the total distance moved by the bullet. And that's the end of the question. Any questions?
No, sir.
Do we all understand?
Yes, sir.
Yes, sir.
That means you should be able to solve a question like this yourself.
Yes, sir.
Yes, sir.
Okay. So we're done with that. Any other question asked now? Ask now so I can explain it in detail to you. Now is the time to ask. From what we have done so far in class, if you have been following and you have not been understanding, now is the time to ask. No question. Okay, so let's
No
stop here for
questions.
today then. So let's stop here for today then. All right, you guys have a nice day. Goodbye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir.